Now in this question here, we're given a sequence and we're asked to determine a recursive formula for each of these sequences here. Now there's no hard and fast way to determine a formula, a recursive formula for a sequence. I mean, there may not even be one. Okay, but if there is, you should be able to see some sort of pattern. In our first one, we'll notice that each successive term, okay, differs by 4. So there's plus 4 here, plus 4 here, plus 4 here. In other words, to get to the next term, we're just adding 4, starting with 3. So we know how to write this in terms of an arithmetic sequence, the general term, but if we want to define it recursively, we have to set up an equation that involves the current term and it's somehow connected to the previous term. So to do that, let's take just a look at, say, the first two. Let's look at 3 and 7. How do I go from 3 to 7 exactly? Well, I just add 4. Okay, it's very simple. How do I write that though? Well, think of starting with 7 on this side. 7 goes over here. That's going to be the previous term plus 4. Now if I look at the next two terms, say 11 and 7, how do I get from 7 to 11? Well, I start with 7 and then I add 4. Let's take the last two to convince ourselves this even more, 11 and 15. How do I go from 11 to 15? Well, I want to get to 15. I start with 11 and then I add 4. You notice that 4 is the only constant number that appears every time here. So how can I generalize this to any type of, any term in this sequence? Well, what I'm going to do is I'm going to label my successive term, say tn plus 1, as being the sum of the previous term and 4. Okay? And that seems to corroborate the examples that we've done above. In fact, if I wanted to figure out what t of, say, 5 is, well, that's going to be t of 4, because n is 4, plus 4. Well, what's the fourth term? We have 1, 2, 3, 4 is 15 plus 4. No surprise, it is 19. Now for the next one, again, looking at it, you can see that, oh, if I multiply by 2 each step of the way, I'm going to get the next term in the sequence. So again, it's pretty clear that it's a geometric sequence, but how do we write that recursively? So if I write down t subscript n, actually, you know what, let's not even get to the abstract part yet. Let me just write down successive terms and how I arrive at the next one. So 6 and 3, well, 6 is derived from 3 by multiplying it by 2. Let me just reverse the order, in fact. I'll have 2 times 3. 6 and 12. 12 is obtained from 6 by multiplying it by 2. 24 is obtained from 12 by multiplying it by 2. Again, the common element here is always seeing the 2's. How can I write this recursively? Well, the successive term is 2 times the previous one. If I want to, for example, say evaluate t of 5, the fifth term in this sequence, it will be 2 times t of 4, because n is 4. Well, the fourth term is 24. 2 times 24 is equal to 48.